Day 1, we begin finding the area of the region between two curves. When you find an area of a region between the two curves and not just bounded by the x-axis, what we're going to be doing is creating an integral, finding their intersection points. Those will be the bounds, and then we'll take the functions and subtract each other. So we're going to go ahead and just start explaining this using a picture that's already set up. And all we're asked to do is find or set up the definite integral. Don't even find the area, just set it up. So we're going to create an integral. My bounds are where they intersect. So they intersect here on the x-axis from -2 to 2. So I'm finding the area between the regions from -2 to 2. And then when you create this new function, it's always f of x minus g of x. It's the top function minus the bottom function. So this top function is the y2, the line. So we'll put 2x plus 5 minus the bottom function, x squared plus 2x plus 1. And then, of course, we'll put our dx on there, meaning that we are integrating this with respect to x, and these bounds are in terms of x. Let's look at a second example. Again, we're going to just set up the integral. So I'm going to look at where these are intersecting, and they're intersecting when x is 0 and x is 2, so from 0 to 2. We're going to take the top function and subtract the bottom function. Now, argument can be made, well, this has two different functions. Well, in all honesty, you really need to be setting up two integrals for this because of how they change. And first of all, the y1's on top, and then after they intersect again, the y2's on top. So what we need to do is we need to set up an integral from 0 to 1. That would have the y1 on top, so we have x minus 1 cubed minus the y2 function. This would be dx. And then we would be adding 1 to 2. This time the top function is the line. X minus 1 minus x minus 1 cubed. And this would be dx as well. We could talk a lot more about this function, but since we're just setting this up, I want to just go ahead and talk about it in this sense. I'm not so much finding the area right now. We'll talk about that as we progress in this section. See if I can get through one more example. On this problem, what we were supposed to do is actually create the picture. And then we're going to find, we're not going to find the area yet. We're just sketching the graph. So I have two functions here. This is my first one. F of x is equal to 2 minus x squared. And my second function is g of x equals x squared. So f of x looks like this. It crosses at 0, 2, and it's a parabola going down. So what it looks like is a parabola going down like this. My picture is definitely not perfect. Then I have a second parabola. I'll do this one in red. It starts at 0, 0, and it goes up. Here's the region that we would be finding the area of if we were going to solve this integral. Alright, in this next problem, we were supposed to sketch the graph of the function and shade the region whose area is represented by the integral. Now I will mention that this one's a bit of difference because it's a dy problem, meaning that my integral bounds are talking about the y-axis. My first function is 2 square root of y, and my second function is just y. In order to graph these, you may find it easier to make a t-chart. So this first function, I'm going to go ahead and create it as x equals 2 square root of y, and I will create a t-chart for this. What I'm going to do is ask myself questions, and I'm only concerned about when y is from 0 to 4. So when y is 0, x is 0. When y is 1, x is 2. When y is 2, there's something going on, and 3, something going on, but I don't know the exact value, so I'm leaving those off. When y is 4, I end up getting x is 4. So I'm going to go ahead and graph this particular function. Alright, so I've got 0, 0. I've got this in the wrong spot here. I've got 2, 1, and I have 4, 4. That looks a little off to me. But it does go like this. And then the second one is x equals y. Well, that's the same thing as y equals x. So it's a line that's going to go through here and here. And there's my answer. I want you guys to pay attention. When you have a dy integral, notice how the functions are listed. They're listed from the furthest right function minus the left function. Not top minus bottom, but right minus left. In this next problem, we're actually going to be not only sketching the region bounded by the graphs, but we're also going to find the area. And we're doing that from x is 2 to 8. So I'm really only concerned about what's going on from 2 to 8. Alright, this first one, I'm going to actually graph this one first, is a line, and it has a slope of negative 1/2. So down 1 over 2. Down 1 over 2, and I've got to go out to 8. So 3, 4, 5, 6, 7, 8. Down 1 over 2, so now I'm at 4 on the x. Down 1 over 2, now I'm at 6. Down 1 over 2, now I'm at 8. So that's the line. And then this other one is a parabola. It's negative 3/8 x squared, and then those cancel plus 3. What does this look like? Well, I'm going to have to finish this up on the next video. Alright, so continuing on, I have a small correction to make here. I didn't distribute my x through here, so this should be a 3x. I don't know if this is really the easiest way to be looking at this function. What I'm going to do is talk about its x-intercepts first. So it's going to cross at 8, 0, and 0, 0. When x is 0, I get 0 for y, and when x is 8, I'm going to get 0 for y. So that means that its maximum is actually going to occur at 4, and I know it's a parabola. So what I'm going to do is plug in 4 here. So I've got negative 3/8 times 4 times, this would be 4 minus 8, which would be negative 4. That's negative 16 divided by 8 is negative 2 times negative 3 is a 6. So when x is 2, y is 6. So I've got, or 4, excuse me, y is 6. So I'm going to go ahead and put a dot here, create my parabola. Now remember, we're only talking about from x equals 2 to x equals 8. So now I have some bounded territory here. We were going to find the area of this region right here. We're actually supposed to not just graph it, but find the area as well. So I'm going to create my integral. My integral is going to go from 2 to 8 on the x-axis. The top function is the line, so 10 minus 1/2 x minus the bottom function. And I will go ahead and put it in this form. Negative 3/8 x squared plus 3x, and then dx. So what that's going to give me is a new integral, 10 minus 1/2 x, and this would be plus 3/8 x squared minus 3x. Alright, so when I combine my like terms, I end up with a 10, and this would be a negative 3.5, which would be a negative 7/2 x plus 3/8 x squared. So now I'm ready to integrate. I'm going to say this is 10x minus, this would be 7/2 x squared over 2 plus 3/8 x cubed over 3. And I'd be computing this from 2 to 8. So I end up getting 10x minus 4/7 x squared plus, it would be x cubed over 8. And I'm going to plug in the 8 first. So I'd have 80 minus 112 plus 64. And then minus, plug in the 2. I'd have 20. Plug in the 2 here. I'd end up with minus 7. Plug in the 2 here, plus 1. When I combine those all together, I should end up with the answer of 18. Okay, and the next problem, I will just get it started. I will not be able to finish the whole thing. I'm going to start by sketching the graph. This time I don't have any bounds, so what I have to do to find the bounds is I have to find their points of intersection. So I'm going to start there. Move everything to this side. So I've got x squared be minus 3x, and then I'd have to subtract off 1, so it gives me 0. So it's going to be intersecting at x is 0 and x is 3. So my integral is going to go from 0 to 3, and so is my picture. So this is a line, starts at 1, has a slope of 1. So I'll go up 1 over 1, up 1 over 1, up 1 over 1, and I'll draw that in. And the second one is a parabola. I'll see if I can get it drawn. If I plug in 0, I get 1. And what it does is it is going down. It doesn't really matter how high it goes, just so you know. We just know it's going to intersect here. So I'm going to be finding this area. So we're going to find this area, this region. I just created this graph. And the integral does go from 0 to 3. The top function is the red function, so I will say that it is the negative x squared plus 4x plus 1 minus the bottom function x plus 1 dx. So I'm going to end up getting negative x squared. This is 4x minus x, which would be a 3x. And then I have 1 minus 1, which is 0. And so when I integrate, I get negative x cubed over 3 plus 3x squared over 2 from 0 to 3. So I'm going to plug in my 3 first. So I get a negative 9 plus, plug in my 3. I get 27 divided by 2, 27 halves. And then when I plug in 0, I get 0. And when I add those together, I end up getting 9 halves. Last example for this section is in terms of y. So this is a dy. First thing I want to do is figure out where they intersect. And remember, everything's in terms of y, so we have to change up our thinking just a little bit. So if 2y minus y squared equals negative y, I end up getting y squared, move the 2y over, so it's a negative 3y. Again, this factors, and I get y is 0 and y is 3. So my integral will go from 0 to 3, but it's going to be a dy. Remember, we're talking about the y-axis. This is a line. It'd just be like x equals negative y, but it'd be y equals negative x. That'd be graphing. So let's see here. That's the portion of the picture I'm talking about. And then this one, again, we're just concerned with where they intersect and how it begins to look. So I'm just going to pick a couple points like 0. If I put 0, I get 0, 0. If I pick, and I'm talking about for the y, I'm picking points for the y. If I pick 1 for the y, I get 1 times 1, which is 1. So 1, 1 is over here. So that means my parabola is going to look something like this because I know it's going to intersect at 0 and at 3 on the y-axis. I don't have to have a perfect picture. I just need to have a sketch so I can have an idea how I need to set up my integral. So I'm going to move this over just a little bit. And I'm going to say I'm going to integrate from 0 to 3. And in this case, since it's a dy problem, we have to go right to left. So this was my right function. So 2y minus y squared minus my left function, negative y, dy. So I'm getting 2y minus y squared plus y, which will reduce to be then negative y squared plus 3y dy. Integrate, raise it by 1, put it over the value, and then plug in your values of 3 and 0. When I plug in 3, I end up getting negative 27 over 3 plus, plug in 3, I get 27 over 2 minus 0. This will add up to be 9 halves again.